So what we have in this problem are two particles. One is particle P1, which is at a distance of d1 from the origin, and it has velocity v1 pointing in this direction. And then you have particle P2, which is at a distance d2, and its velocity vector is v2 as given over here. So the respective values are also given over here. And the question is, what is the angular momentum of the particles about the origin? So we have to find the angular momentum due to P2 at the origin and the angular momentum due to P1 about the origin. And then we can probably go ahead and find the net angular momentum about the origin due to these two particles. So how we'll approach this problem is that we'll first find the angular momentum L1 about the origin due to particle P1. And we know the formula for finding the angular momentum about the origin is nothing but the product of mass into the cross product of r with the velocity vector v. So let me remove this multiplication sign over here and let me rewrite it as mr cross v. Otherwise it will look like we're doing a cross product of m with the cross product of r and v. So we'll write the angular momentum as the product of mass multiplied by the cross product of r with the velocity vector v. And the velocity vector here is v1. And we know that the position vector of this particle is nothing but this. Its magnitude is d1 and it's pointing in this direction. So let's go ahead and substitute the values. What we have is m1 is equal to 6.5 kilograms multiplied by the value of position vector r1 is 1.5 meters multiplied by the velocity vector, which is 2.2, into the sine of the angle between position vector r and the velocity vector v, which we can see is 90 degrees. It's given that this is 90 degrees. So what you find is the value of this L1 comes out to 21.4 kilogram meter square per second. Now the question is, what is the direction of this vector? Because we know that the angular momentum is a cross product of position vector and velocity vector, so it has to be perpendicular to both the vectors r and v. And how we find the direction is using the right hand rule. You can refer to it in one of the lessons we have done earlier. And when you sweep vector r towards vector v, what you find is that it is into the page, or it is in the negative direction of z-axis. So we label this as negative. Now let's go ahead and find what is the angular momentum of P2 about the origin. And we'll have a similar approach. L2 is nothing but the product of mass m2 with a cross product of r. And let's call this over here r1. r2, which is nothing but distance d2 and pointing in this direction, with cross product of r2 with v2. And let's go ahead and substitute the values. What you'll find is m2 is equal to 3.1 kilograms multiplied by r2, which is 2.8 meters in magnitude and pointing in this direction, and v2 is 3.6 meters per second into sine of the angle between the two vectors, which is 90 degrees. And what you find is this product is equal to 31.2 kilogram meter square per second. To find the direction of this vector, what we'll do is we will once again use the right hand rule and sweep the position vector r2 in the direction of vector v2, and the direction of the thumb would give the direction of the resulting vector. And we can see that the direction of the resulting vector is upward or out of the screen in which you are seeing. So it's in the positive z direction, and therefore it is positive. So to find the net angular momentum about O due to these two particles, we'll sum up the two vectors. And let's not forget that this is a vector, so we need to put a arrow on top. So the net vector is nothing but the sum of vector L1 and vector L2. And when we do so, what we find is L1 is minus 21.4 and L2 is 31.2, and the result is 9.8 kilogram meter square per second. And we can see it is a positive value. Therefore, the net angular momentum about O due to these two particles is pointing in the upward direction or the positive Z direction.